So in first chapter we have seen, say suppose there is a shaft or there is one object. It can be any cross section, maybe rectangular cross section, if not circular cross section. We'll apply some force here, and whatever stress developed here, this is known as direct stress, sigma direct. And sigma direct is given by the equation force divided by area. Which area you have to consider? You have to consider cross sectional area. So force is acting in horizontal direction, so area which is perpendicular to that, or cross sectional area, this area we have to consider. And here strain is given by epsilon delta L, or change in dimension divided by original dimension. So using these two equations, you can calculate stress and strain. And there is one more relationship between stress and strain, that is given by E is equal to stress divided by strain. E means that is Young's modulus or modulus of elasticity. So modulus of elasticity is given by, it is the ratio of stress divided by strain. Here in denominator it is not E, this is epsilon. This one is epsilon. So these are the basic equations from first chapter. And if the force is compressive in nature, then sigma will be negative. This value will be negative. Now in the same or similar type of problem, instead of applying force in x direction, we'll apply force along y direction. I'm applying either tensile or compressive force along y direction. So even in this example, in order to calculate stress and strain, we are using same equation. There is no change in equation. Sigma direct is given by force by area, but since it is compressive force, sigma value will be negative. This will be negative. And strain is given by change in thickness here, because when you apply force in perpendicular direction, or when you apply force in vertical direction like this, its thickness is going to change. It will not affect the length. Obviously it's going to affect the length, but here actually strain is given by change in dimension divided by original dimension. It need not be change in length in every case, but since I'm applying force along the thickness, epsilon equation will be delta T divided by T. And even here Young's modulus is given by stress by strain. Young's modulus is equal to stress divided by strain. So apart from these two topics, we have seen in the first chapter definition of Poisson's ratio. So usually they will denote Poisson's ratio using either mu, if not 1 by m, or 1 by m. So mu and 1 by m, it is same Poisson's ratio. And what is Poisson's ratio? Poisson's ratio, it is the ratio of lateral strain divided by linear strain. So mu is given by lateral strain divided by linear strain. This is Poisson's ratio. And in most of the applications, this mu value will be around 0.3. It will be less than 1. Why it is less than 1? Because for that I should explain what is lateral strain and linear strain. Lateral strain means, you consider this first diagram, or we'll draw it once again here. consider this first diagram. I'm applying force along x-axis. When you apply force along x-axis, its length is going to increase. Length of this object will increase. Length of this object is going to increase, and to compensate the total volume, its thickness is going to drop. If this one is the thickness, say this is the thickness of the object and this one is the total length of the object. When you apply force along x-axis, its length will increase, its thickness will drop. So lateral strain means that is delta T, change in thickness divided by original thickness, delta T divided by T, whereas linear strain means delta L divided by L, change in length divided by original length. So that is about lateral strain and linear strain. So the ratio of lateral strain to linear strain, that is known as Poisson's ratio. We'll denote it using mu, if not 1 by m. And why it is less than 1? Because always this linear strain will be compared to lateral term. This mu value will be less than 1, usually in the range of around 0.3 to 0.5, approximately 0.3 to 0.5. You need not remember all these things. You just have to remember what is Poisson's ratio. That is lateral strain by linear strain. Understand what is lateral strain, that is the ratio of delta T divided by T, whereas linear strain means it is delta L divided by L. And one approximate, if the value of mu is not given in the question, you can assume mu as 0.3. So these are the basic things from the first chapter, and before going for second chapter, so these things are required. These are like foundation for the second chapter. And in the second module, I told you there are two chapters. First one is analysis of stresses and strain, and second one is cylinders. The cylinder is already over. In today's class, we'll start analysis of stresses and strain. Okay, then why exactly this chapter is required? What is the difference in first chapter and second chapter, or module 1 and module 2? So let me tell you. So just now I told you I have given different diagrams. In all the diagrams, if you consider, force is acting along one particular direction. If you consider this first diagram, force is acting along x-axis only. If you consider second diagram, force is acting along y-axis only. Again, if you consider third diagram, there is only one force along x-axis. But did you ever think, in the same system, if I introduce one more force along x-axis also, or some other axis, maybe z-axis, so in such case, how can you calculate stress, strain, or how can you calculate different reactions developed in the object? So under this chapter, we will study when number of forces are acting on a system. It can be forces along x-axis, forces along y-axis, and sometimes forces along z-axis. This force along z-axis, it's not there in your syllabus. So usually for you, only two forces are included: forces along x-axis and forces along y-axis. Apart from this, sometimes they can also introduce one shear stress. One more shear stress they can introduce like this. Shear stress means a force which is acting parallel to surface of the object, not perpendicular, parallel to surface of the object. So in that case, how to calculate resultant force, resultant stress, resultant strain, all these things. So we're going to study about these things in first chapter of second module. So usually in this chapter, diagrams will be like, or the object will be like, most of the cases we will be dealing about a rectangular object only. There will be one force along x-axis. For this solution is simple, sigma x is equal to force by area. Only one stress will be acting, only one stress will be developed, that is given by force divided by area. This is force divided by this cross-sectional area, you will get stress. But if one more force is acting perpendicular to previous force, then the procedure to calculate resultant force is slightly different. You cannot calculate resultant force like sigma x is equal to F by A, sigma y is equal to F by A. Like that you cannot calculate. So in next slides we'll tell you how to calculate resultant stress when more than two forces are acting. And the meaning of this arrow mark is, it is a shear stress. This is a normal force along x-axis. This is force along y-axis. This is again force along x-axis. This one is force along y-axis. Whether all the forces are tensile or compressive. These forces, if you consider, all the forces are tensile in nature. Compressive force means this one is compressive. If it tries to compress the object, it is compressive force. Compressive force is negative in nature. But here all the forces are trying to pull the object, so all the forces are tensile and these are positive in nature, positive forces. And so in the same diagram, if you consider, there are four more lines. This one, all the lines indicated in blue color. These lines represents shear forces. These are the shear forces. I told you for normal force there is positive and negative. Positive means it is a tensile force. Compressive means it is a negative force. But what about this shear force? Whether shear force, for shear force also the sign consideration is required or not? Or how to consider sign for shear force? We'll tell you that now. So here this square, if you consider, these two are the positive corners of the square. So if a shear force is acting towards positive corner of the square, then these two shear forces are positive in nature. Here shear force, it is positive in nature because it is acting on positive corner of square. Whereas these two corners are known as negative corners. This is negative and negative. And if a shear force is acting towards negative corner of the square or negative corner of an object, then that shear force is known as negative shear force. So here shear force is negative in nature. In first diagram, shear force is positive in nature. So only these two cases are possible. You cannot draw like this. You cannot draw like this. One towards negative force, negative corner, one towards positive corner. Like that you cannot construct. So only two cases. One as shown in first diagram. Second one here. First one is positive shear force, and second as shown in this diagram, negative shear force. Shear force, and in that second diagram, shear force is negative. In this diagram, shear force is negative. So moving on to next slide. So in this chapter, we will also study. So one thing what we're going to study is if more than one forces are acting on a system, how to calculate resultant stress, resultant strain, etc. And the second thing what we're going to study under this chapter is you consider one object as shown in first diagram will apply one or more number of forces. It can be only Fx, or you can assume Fy is also acting. So in all these cases, you consider one inclined force, inclined plane as indicated by red line. So here Fx and Fy, two forces are acting.
Sir, you're not audible.
So front view of the same diagram is shown here. Just 2 more minutes. Front view of the same diagram is shown here. In front view, this plane is making an angle of theta with respect to vertical. Same thing is shown here. It's making an angle of theta with respect to vertical. And even here it is making an angle of theta with respect to vertical. Angle theta. We have to calculate what is the effect of this Fx on the inclined plane, which is inclined at an angle of theta with respect to vertical. Mm. Am I audible now? Whether the problem has resolved or?
Now it is correct, Professor.
Okay. Actually, in the beginning of this chapter, there is one derivation. One second. A derivation about how to calculate resultant force or resultant stress if more than one force is acting on a system. But that derivation part will explain later. You can take down final equation. You have to remember all these equations. You can note down, or else you can take a screenshot of this one. Resultant normal stress of sigma x and sigma y, that is given by, this is normal stress, sigma n is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 into cos 2 theta. What is sigma n and what is theta will tell you later. What is resultant normal stress and what is resultant tangential stress will tell you later. And second equation, resultant tangential stress or shear stress. Usually they will use word resultant tangential only. That is given by minus of sigma x minus sigma y by 2 into sine 2 theta. And resultant of these two, resultant of sigma normal and sigma tangential is given by square root of sigma normal square plus sigma tangential square. And inclination of resultant plane, that is given by phi is equal to tan inverse sigma t divided by sigma n. And one last equation, to find out maximum or minimum shear stress, that is the difference between sigma x and sigma y divided by 2, plus or minus sigma x minus sigma y divided by 2. Now let me tell you what is this sigma n, sigma t, and plane of obliquity. So all those things will tell you. So you consider one object. Two forces are acting. One force along x-axis and second force along y-axis. And because of this force, one stress is developed along x-axis, sigma x. And because of this vertical force, one stress is developed along y-axis also, that is sigma y. So two stresses are developed, sigma x and sigma y. And my intention is to find out resultant of sigma x and sigma y in a plane which is inclined at certain angle theta with respect to vertical. So this diagram will be given in the question in most of the problem. They will give you sigma x value, they will give you sigma y value, they will give theta also, and question will be like, in the diagram shown, calculate resultant normal stress on a plane which is inclined at 30° with respect to vertical. Calculate resultant tangential stress. Calculate resultant stress, angle of obliquity, and maximum or minimum shear stress. So like this they will ask. Then resultant normal stress means Hello students, I'm using my mobile data now. Hope it's audible and screen is visible. So I was explaining about these equations. So we have to use this equation only when more than one force is acting on the system. Sigma x and stress along y-axis sigma y. And in order to find stress on one inclined plane, which is inclined at an angle theta, we can use these equations. And in this equation, sigma n means to consider this plane. In this plane, I cannot calculate a resultant stress value directly. So instead of calculating resultant stress value directly, what I will do is first I will calculate what is resultant normal stress, then we'll calculate resultant tangential stress. So using these two, we'll calculate resultant stress. So resultant normal stress means it is a stress which is acting perpendicular to given plane. So we'll draw one more neat diagram. This is the object given. Plane is inclined at an angle theta with respect to vertical. So here sigma n means in this inclined plane, I told we cannot calculate resultant stress directly. We will calculate components of resultant. Components are one is sigma n normal stress which acting plane and tangential stress. So resultant tangential stress will be acting parallel to given plane. So this is sigma t tangential stress. Then the resultant stress will be acting. Resultant stress means resultant of sigma n and sigma t. So somewhere here sigma resultant will be acting, sigma resultant. And here angle of obliquity means that is the inclination between sigma n and resultant. This one is known as angle of obliquity. So we have to calculate these many things in the problem. We have to calculate what is the normal component of resultant sigma n. We have to calculate what is the tangential component of resultant, that is sigma t, using this equation. Using sigma n and sigma t, we can calculate resultant sigma r, then find out inclination of resultant stress, and the last one, maximum or minimum shear stress using equation plus or minus sigma x minus sigma y divided by 2. Here when you consider plus sign, you will get maximum shear stress, and when you consider minus sign, here when you consider minus sign, you will get minimum shear stress, tau minimum. So note down these equations or else take a screenshot of this one. You can draw a diagram also. What is sigma n, what is sigma t, all those things. Sigma n means it is a stress which is acting perpendicular to inclined plane, sigma n. Sigma t will be acting parallel to inclined plane, sigma t tangential component. And the last one, that is the resultant. Resultant means resultant of sigma n and sigma t. That will be resultant stress. And this inclination is angle of obliquity, phi. So a problem based on this, Usually they ask this kind of problem for around 10 to 12 marks. So we'll solve this problem and we'll wind up. A point in a strain material is subjected to a tensile stress of 500 Newton per mm square and 300 Newton per mm square in mutual perpendicular planes. Calculate the normal, tangential, resultant stresses and its obliquity on a plane making an inclination of 30° with second stress. Here second stress means two stresses are given, 500 and 300. So making an inclination of 30° with second stress means making an inclination of 30° with 300 Newton per mm square, which is the second stress, and also find maximum shear stress. So you can draw one. So two stresses are acting, sigma x and sigma y. Here it is not mentioned out of these two values, 500 and 300, which is sigma x and which is sigma y. It's not mentioned. You can assume 500 as sigma x and 300 as sigma y. Since they did not differentiate between sigma x and sigma y, we'll assume 500 Newton per mm square as sigma x, this one sigma x, and sigma y is equal to 300, will assume. This one 300 will assume. And what you have to calculate is, consider one inclined plane. This plane is making 30° with the second stress. So which angle is 30° here? So this plane should be making 30° with second stress. Second stress is acting horizontally or vertically. Second stress is acting vertically. That means plane is making 30° with vertical. So with vertical, this plane is making 30°. So this is 30°, or else here also you can mark 30°. So this is the given problem. You have to find out what is normal stress. Normal stress is sigma n. And what is the equation to calculate sigma n? We have seen in the previous slide. This is the equation to find out sigma n. Sigma n is sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 into cos 2 theta. Cos 2 theta. Substitute all the values. Sigma x is 500, sigma x is 500, sigma y is 300, sigma y is 300, and theta is 30°. Theta is 30°. Substitute all the values and you will get sigma x, this is 500, sigma y is 300, theta is 30°, and here cos 2 theta, so cos 60°. You will get answer 450 Newton per mm square. 450 Newton per mm square. This is sigma n, normal component. Now calculate tangential component also. Tangential component sigma t is equal to, equation is given in the previous slide, minus sigma x minus sigma y divided by 2 into sine 2 theta. Minus sigma y divided by 2 into sine 2 theta. You know all the values. Sigma x is 500, sigma y is 300, theta is 30 degree. When you substitute, you will get sigma t as minus 86.6 Newton per mm square. Minus 86.6 Newton per mm square. So using this sigma n and sigma t, calculate resultant stress. Sigma r, resultant is given by square root of sigma n square plus sigma t square. Sigma n square plus sigma t square. So square root of 450 square plus 86.6 square. (450 square plus 86.6 square). You will get answer 458.26 Newton per mm square. 458.26 Newton per mm square. So what all things we have calculated now? We have calculated what is the normal stress. We calculated what is the tangential stress. Resultant stress is also over. Last two more things. Obliquity is required and also maximum shear stress. So next step, calculate obliquity. Phi. Phi is given by tan inverse sigma t divided by sigma n. Sigma t divided by sigma n. So while considering sigma t, you have to write minus 86. So that becomes tan inverse minus 86.6 divided by 450. You will get answer minus 10.89. This answer, this one has to be tan inverse. Minus sign also you have to consider. Minus 86.6 divided by sigma n is 450. So this answer you will get minus 10.89. Minus 10.89 degree. So what is the meaning of inclination being negative? So inclination is negative means, before telling that, we'll mark above answer in this diagram. Sigma n is 450. That means sigma n will be always acting perpendicular to given plane. This is sigma n. You can mark sigma n, sigma t, all those things in this diagram. This is sigma n. Sigma t will be acting parallel to given plane. So this is sigma t. This one is sigma t. Sigma n is over, sigma t is over. Then resultant stress, its magnitude is 458 and it is inclined at an angle of 10.89 with respect to sigma n. I told you meaning of phi is, this is the inclination of resultant stress with respect to sigma n. So its meaning is sigma r is inclined at an angle of 10.89 from sigma n. Now we'll tell you what is the meaning of negative. Means sigma clockwise direction. So if you measure the angle in clockwise direction, then angle is negative. That means from sigma n will measure angle in clockwise direction, in this direction. This is the clockwise direction. So from sigma n in clockwise direction at an angle of 10.89, resultant stress sigma r is acting. So this is the resultant stress, and this angle is phi. Phi is equal to 10.89. That is negative. Negative means from sigma n it is acting in clockwise direction. So even that thing is complete. Now the last question, find maximum shear stress. We have the equation to calculate maximum shear stress. Maximum shear stress is given by plus or minus sigma x minus sigma y divided by 2. So tau max will write maximum shear stress tau max. Equation is plus or minus tau max is equal to plus or minus sigma x minus sigma y divided by 2, where sigma x is 450, sorry, sigma x is 500, sigma y is 300. This one is 500 and sigma y is 300. So when you simplify, you will get plus or minus 500 minus 300, it is 200 by 2, you will get plus or minus 100. So what is the meaning of plus or minus 100? Here, this is not only tau max, it is tau max and minimum. Maximum shear stress is plus 100 Newton per mm square, whereas minimum shear stress is minus 100 Newton per mm square. So that is the meaning of plus and minus. So that completes this problem. Direct substitution, go through question. We have ready-made equation. Substitute, represent all these values in the diagram. So that I did in the previous slide. So like this, you have to represent all the values, sigma n, sigma t, resultant, and also this angle phi. So all these things you have to represent. And this kind of question they ask usually for around 10 to 12 marks.